Hey, I apologize for not being here today, but compelling reason I had to run someone to um, a very, very critical doctor appointment. Um, and I was the only one available. Okay, so we have a system of three equations here, and this is our quiz. You've done the work on systems of three equations. So here is a system of three equations. Ask you to solve that as your quiz. Okay, now you've done your best to solve the system. Hopefully you solved it correctly. How are we going to solve the system? Well, we're going to eliminate one of the variables from each of two equations. Now we can look at eliminating z. It would be easy to eliminate z between equation 2 and 3 because if we just double all the numbers in this equation, we get a negative 4z. Add that to this equation, which has a 4z, and the z's go away. But then there's no convenient multiple of either of these equations. It'll get rid of the negative 7. We could multiply the second equation by 7/4, and that would get rid of the negative 7z. But the rest of the equation would have some kind of ugly fractions in it, and we'd try to avoid that. Can't always avoid it, but we do if we can. Okay, and similarly for y, the 3 and the 6 match up well. We double this, and we get rid of the 6y. But then to get rid of the 5y, we'd have to have a 5/3 or a 5/6 involved in the multiplication because it'd be difficult to get rid of that 5. For the x's, it turns out to be easy. We multiply the third equation by negative 4, we'll get a negative 4x to match this 4x. If we multiply by negative 2, we'll get a negative 2x to match this 2x. So that adding negative 4 times the third equation to the second will eliminate x. Multiplying third equation by negative 2 and adding it to the first will eliminate the x out of this equation. That will leave us two equations in y and z, and it's generally, well, we already know how to solve two equations in two unknowns. So let's just look at the details. I've already worked out the details. So here are the three equations again. We want to try to eliminate x. We'll just say using the third and the second equation. So we take negative 2 times the numbers in this third equation, add that equation to the first equation. So we do negative 2 times the third equation plus the first. Gives us this result. Then we eliminate x from another pair of equations. Multiply this equation, third equation, by negative 4 and add it to the second. Negative 4 times the third equation added to the second gives us this. Now, you should do that and verify it. Don't just take my word for it, do it and verify it and make sure these equations are correct. Now, when we're solving this, first of all, look at the overview. Our strategy is to eliminate the chosen variable from each of two pairs of equations. What variable did we choose? Well, we looked at z, that wasn't going to work as well. We looked at y, that wasn't going to be easy to eliminate. We looked at x, we find that's easy to eliminate. We just used multiple of the third equation to eliminate x between the third and the second, and then a different multiple of this equation to eliminate x between the third and the first. Here's what we have. Now, when we do that, we just don't do it in our head. I can do it in my head, but even if I write it out, I tend to make mistakes, tend to get in a hurry and write things down carefully. So what we do is we write negative 2 times the third plus the first. We write negative 2 times the third equation here. We write the first equation here, then we add what we get. Okay, -2 times the third equation, coefficient of x is 1, multiplied by -2, we get -2. Multiply the 6y by -2, we get -12y. Multiply the -2z by -2, we get plus 4z. Multiply the 11 by -2, we get -22. Then we write down the first equation and verify that this is multiple of that this is just the first equation. Then we add what we have. -2x and 2x gives us 0. -12y and 5y gives us -7y. 4z and -7z gives us -3z. -22 and 5 gives us -17. So that will be the equation. 2 times equation third, 2 times equation 3 added to the first. -2 times equation 3 added to the first, and here it is. Similarly, we're going to have to multiply the third equation by -4 to match up the x with this 4x. So we do -4 times the third equation plus the second. Here it is written out. -4 times the third equation is -4 times x. And then -4 times 6y gives us -24y. -4 times -2z gives us plus 8z. -4 times 11 gives us -44. We write second equation, 4x minus 3y plus 4z equals 2 right there. And we add the results and we get -24y, -3y is -27y. 8z and 4z is 12z. -44 and 2 is -42. And of course, the -4x and plus 4x give us 0. So here's our second equation of this pair. So it's straightforward then to solve these two equations for one of the unknowns, for y or for z. Which one are we going to do? Well, -3 and 12 match up. 4 times -3 is 12. So it's going to be easy to eliminate the z's. 7 and 27 are relatively prime. That's going to be a pain. We're going to eliminate z. So we do -3 times the first equation. It should be -4 times the first equation added to the second. Now I'm going to do that just by, actually I've sort of done it down here, but I did the wrong multiple. So the second equation is -27y plus 12z equals -42. And 4 times the first equation of this pair is -28y minus 12z equals -68. Okay, these numbers are kind of big. They're not all that encouraging, but 12z minus 12z is going to give us 0. -27 and -28 is -55. So we're going to have -55y. -42 and -68 is 110. So we get y equal, well, I'm just going to add addition. So I'm going to get -55y equals -110. Now how are we going to solve that? Well, now we solve for y. -55y over -55 equals -110 over -55. So y equals 2. All right, that came out nicely, as I intended it to. What do we do next? We substitute y equals 2 into one of these two equations here. Okay, so we substitute y equals 2 N2. This equation has smaller numbers, so we'll use it. Negative 7y minus 3z equals negative 17. What's that give us? It gives us negative 7 times 2 minus 3z equals negative 17. Well, that's negative 14 minus 3z equals negative 17. We add 14 to both sides. And we get negative 3z equals negative 3. I've skipped a couple of steps here. Don't skip steps unless you're really comfortable with all this. Fill in the steps that I skipped. We get z equals 1. Now, I'm not going to do it. You know what the next step is. We plug z equals 1 and y equals 2 into any one of these three equations. I'll just do it by pointing. If z equals 1, this equation becomes 2x is negative 7z is going to be negative 7. If z equals 2 plus 5y is going to be 10y, so we have 10 minus 7, which is 3. So 2x plus 3 equals 5, and we're going to find that x equals 1, and that works. Now you want to write that step out. I'm not going to do that. I'm going to leave that as a step for you to do. Again, plug in y equals 2 here, plug in z equals 1 here, and you're going to solve and get x equals 1. Then plug 1, 2, 3 in for x, y, and z. And each of these equations is going to be satisfied, which is a complete check. So be sure to check. And I'll just write down here. Chuck isn't cooperating with me down here. So I'm saying, since it's equals 1, y equals 2 into this equation, solve for x and check. Now let's use a different set of equations. So rather than do a second set of equations, we're going to solve the same system, but we're going to use augmented matrices. So the augmented matrix for this system, and you'll not be surprised by this, as long as you've done the work and understood two systems, two variables. The augmented matrix is going to consist of the coefficients 2, 5, negative 7, 5, 4, 3, 4, 2, 1, 6, negative 2, 11. This column consists of your x coefficients. This column your y coefficients. This column, your z coefficients. In the last column, the numbers to the right of the equal sign. First row represents the first equation. Second row represents the second equation. Third row represents the third equation. Now, I'm going to interchange the first and third row. So the rows are 1, 2, and 3. I'm going to write row 3 from above is row 1. So they belong. I won't write the wrong number. It's frequently. Okay. And then we have so this row is row 3 from the previous matrix. Row 2 is the same. Row 1 is the old row 3. Row 3 is the old row 1. Now what I want to do label this row 1, meaning that this is row 1 from the previous matrix. It's still going to be 1, 6, negative 2, 11. Instead of row 2, I'm going to write the old row 2 minus 4 times the old row 1. Because I can see that if I subtract 4 times 1 from 4, I'm going to get 0. Okay, well, when I do that, and we need to write that out somewhere else. I'm going to write it over here, but I'm going to erase it shortly because I'm going to need a little more room. But I'm going to do, okay, row 2 is 4, negative 3, 4, 2. Okay. In other words, at this stage, row 2 is the row 2 from previous matrix. Okay. Then 4 times row 1, negative 4 times row 1. Be careful. Take negative 4 times 1, we get negative 4. Negative 4 times 6 gives us negative 24. Negative 4 times negative 2 gives us 8. Negative 4 times 11 gives us negative 44. So the 4 minus 4 gives us 0. Here we have negative 27. 4 and 8 gives us 12. 2 and negative 44 gives us negative 42. So this row becomes 0, negative 27, 12, negative 42. Okay. The next thing we want is we want a 0 down here. So we can do row 1, sorry, row 3. This row minus 2 times this row, because 2 minus 2 times 1 is 2 minus 2, which is 0. So we're going to do row 3 minus 2 times row 1. And we're going to end up with a 0 here. Now, I'll write this down for you in a minute, but I want you to work this one out yourself. What's row 3 from this matrix minus 2 times row 1 from this matrix? Start by writing it down somewhere off to the side. Write it out. and do the calculation, see what numbers you get down here. Hopefully you've done so. If you haven't, pause and do it now. Okay, so row 3 is 2, 5, -7, 15. No, it's not 15, it's 5. My dotted line here made it look like a 1, so I almost made a mistake there. Okay. Then -2 times row 1. Well, -2 times 1 is -2. -2 times 6 is -12. -12. That -2 times -2 is +4. And -2 times 11 is -22. Now we add these. If you haven't already done so, add these. Well, then 5, -12 gives us -7, -7, 4 gives us -3, 5 and -22 gives us -17. So now we have -7, -3, -17. Now things get a little bit dicier because the next thing we're going to want is a 0 here. And we don't have real convenient numbers up here. There isn't a convenient way to get rid of that -7 other than to do like 7, 6 the first row. That wouldn't be good because we'd have the 1 there. Or -7 27ths of this row. Sorry, -27. Well, yeah, 27 sevenths. So what we're going to do, instead of trying to get a 0 here, and you'll see why we want 1 shortly, is we're going to get a 1 here. In order to get a 1 here, we've got to divide every number in this row by -27. I'm going to do the second row divided by -27. This 0, it's going to give us 1, that's going to be convenient. But then it's going to give us -12 over 27. And -42 over 27. Now that's our second row. Our first row is going to be as it was. Okay, now -12 over 27 turns out to not quite be as bad as it reduces down to -4/9. And -42 over 27 reduces to -14 over 9. So I'm going to replace these fractions with their reduced form. And I get -9 -14 over 9. I want to get a 0 here. In order to do that, keep row 1, I keep row 2, but to row 3, I'm going to add 7 times row 2 because That'll give us a 0 here. I'm going to erase these side calculations. Now I'm going to do row 3, which is 7, -3, -17. And I'm going to do 7 times row 2, which is going to give us, write out the entire row. Seven times row 2 is going to give us 0, 7, -28/9, -14. We add these up, we get 0, 0. Okay, -3 minus 28/9. -3 is 27/9, -27/9. It's going to give us -55/9. You can do the fraction, just put the 3 over common denominator, you're going to get 27/9, and it'll be negative. And you add the -28/9 and get this. Here, the -17 is -160, 153. -153/9. And when I did 7 times row 2, I didn't multiply my 14 by 7. I got 98. Nine. There's got to be an error here. Hang on. Also got a technical issue. My battery's about to die. This thing doesn't seem to be charging. I think we rescued it. I'm going to pause for a second. Okay, apparently the reason I made a mistake was so that I'd take a closer look at my monitor and realize the battery's about to die. So that kind of saved me. Okay, I made an error here. I'm supposed to divide row 2 up here by -27. That should have given me a positive result instead of a negative. So that 14/9, -14/9 should have been a +14/9 there and there. And when I multiply row 2 by 7, I'm going to get a positive 98/9 instead of a negative. And that kind of saves things. Okay, so now -17 is going to be negative 153 and 98 over 9, which is negative 55 over 9. So what I've got here then is 0, 0, negative 55 over 9, and negative 55 over 9. Finally, I'm going to write it down here so I can write it down a little bigger. I multiply row 3 by negative 9 over 55, which would give us a 1 here and a 1 here. So row 1 is the same as before. Second row is the same as before. Third row is 0, 0, 1, 1. This matrix is what we call an upper triangular matrix. Process is get zeros down below the number in your first row, first column. So you want to change this column to a 1 followed by zeros. Then we want a 1 here. And we're going to use that 1 in the next step to get a 0 here. At that point, we just have a number here and a number here. We want to get a 1 here. Now, why do we want 1s in these places, especially in this place? Well, if we translate this matrix into equations, what we get is x plus 6y minus 2z equals 11 from the first equation. Second equation, there's no x in here. There's a y minus 4z. It's not 4z, it's 4/9 z. The last one is 1z equals 1. We can now substitute z equals 1 in the second equation. Now do that and see what you get. Okay, gave you time to get it. What we're going to have is y minus 4/9 of 1 equals 14/9. If we add 4/9 to both sides, we get 18/9, which is 2. We get y equals 2. And we plug y equals 2 in here and z equals 1 here. We get 12 here. And we get 1 here, which is, wait a minute. Y equals 2 gives us 12. Z equals 1 gives us 14. We subtract 14 from both sides. And we get something that we probably shouldn't be getting. We should get x equals 1, and it doesn't look like we do. get x equals -3, which indicates that I probably made an error here because never mind. The only error I made was this is -2. I wrote +2. Okay, that's going to work. Now, if we plug z equals 1, y equals 2 in here, see what we get. But you should have done that. And you should have gotten x equals 1. I'll write out the details. Here. And that's going to give us the equation. Write it in a different color. -4/9 times 1 is 14/9. 4/9 times 1 is just 4/9. And we get y equals 14/9 plus 4/9, which is 18/9, which is 2. Now we take that 2, and we have our z equals 1. We plug that here, and that gives us 6 times 2 minus 2 times 1 equals 11. That's still not right, is it? Awful close. So we should get x equals 1. If you got x equals 1 when I said you should get x equals 1, that was wrong. I'm trying to see where that 11 came from. Hasn't changed. The rest of the equation. Some kind of a logic to understand why we did get x equals 1. We get x equals 12 minus 2. Never mind, we get x equals 1. Getting late in the day, I apologize. So that's x plus 12 minus 2 equals 11. X plus 10 equals 11. Subtract 10 from both sides. You get x equals 1. Now this process, when we got, okay, first couple of steps are pretty easy. When we got down to the fractions, it got a little more complicated. On the other hand, we didn't have to keep writing down our x's and y's. And most importantly, this is the process that a computer program would follow to solve the equation. Simply row reduce this matrix, and that's a simple command that'll go into a computer. I want you to see it. Probably won't test you on the process except for 2 by 2 matrices, the augmented matrix, but that's the way it's done. That's the way it works out. Now we could also add 4/9 of this row to this row. And we would end up again with 1, 0, 2. We could add 2 times this row to this row. And previously, we could have added -6 times this row to this row to get a couple of zeros here. But we're not going to worry too much about that in this course. You've seen enough. Now, there's still the idea of matrices that we'll be talking about. Well, actually, I need to talk about that now, don't I? Okay, so we'll talk about how to translate some of these things to matrix form, and pick up on that in a minute. Okay, just to kind of summarize, and we're not going to do matrices in this video. We'll do this uh, in class on Thursday. We'll do matrix multiplication and so forth. Excuse me. Okay, so if we have a 2 by 2 matrix, let's recall we've already seen this. You got 2 rows of numbers, 3 numbers in each row. The line here indicating that this is something times x, this is something times y equals something. And similarly here. Okay, so just an asterisk will be whatever number happens to be there. What do? We start by dividing the numbers in the first row by whatever this first number is to get 1. We add a multiple of the first row to the second row to make this number 0. Then we divide this number by itself. So we divide everything in this row by whatever this number is. It'll give us 1 here and some number here. So we're going to get 1. At this stage, if our variables are x and y, we know what y is equal to. We could plug that back in here and solve for x. Alternatively, we could add a multiple of this row to this row. And then we'd know what x is, and we wouldn't have to mess with an equation. It's going to come out to the same thing. So we start with a matrix, get a 1 here. Keep the 1 forever, get a 0 here. And then keep the 1 and the 0, get a 1 here. And then keep those 1s and 0s that we already have and get a 0 here. Now you have to choose the right multiples and do the right steps, but it's fairly straightforward. Now it's a little more complicated when we have a 3 by 3 matrix, but just a we got 3 rows, 4 numbers in each row. Possibly by switching rows, because it doesn't matter in what order the equation happened to be written down, the solution is going to be what it is. So if this matrix represents, say, this system of equations, then you notice that we switched the third row with the first. We still have the same 3 equations represented. They're just in different order. And the reason we did that was to get a 1 here. You can't always do that, but you can rearrange the order of the equations in a way that makes it as convenient as possible. But one way or another, we get a 1 up here. Nothing else. Whatever number is here, we can divide this row by that number to get a 1. As we would do over here. Now, having gotten our 1 here, we can add multiples of this row to this row and this row, different multiples in most cases, to get zeros. Then we get a 1 here. Divide this row by whatever this number is. Now, well, there are other cases, if you got a 0 here already, what are you going to do? Okay. Well, you're probably going to switch this row and this row, but we're not going to talk about that right now. We're going to keep the scheme as simple as possible. You get a 1 here. Now that you have a 1 here, it's easy to figure out what multiple of this row to add to this row. And having done that, you're going to have this. And then finally, you're going to divide this third row, which has 2 zeros to start, by whatever this number is to get a 1. That's the sequence of things that you want to see. Now, sometimes, as I said, maybe you have 0 right here. Okay. Well, if you've got 0 right here, switch this row with another row that doesn't have a 0. You get one of your zeros here done for free, but adjust the order of your rows so you've got something besides 0 here before you do this. Otherwise, you can't get 1. And similarly, down here, if this number happened to be 0, then you'd probably want to switch with the third row in order to get something that isn't 0 here. Now, it is possible to have 0 here and 0 here at this step, in which case, well, I don't want to address that without an example. I mean, I can say if when you divide this row by this number and this row by this number after you have the zeros here, if you come out with the same thing, great. You have something that's useful. I don't want to say any more than that. But it also means that your system was what we call degenerate, and we're not going to get into degenerate things in this course. So there are cases where this scheme isn't possible to achieve. And in those cases, you have a system which we do call degenerate. And again, we're not addressing that. Okay. So you do what you can to follow the evolution of the system. So you have 1 here, then you have 2 zeros, then you have all that, then you have a 1, then you have all that, but you get a 0 here, and now you have upper triangular form, which means if your variables are x, y, and z, you know what z is. You can put that in for z in the second equation, translate this into equations, and now you know z and y, and you plug that into the first equation and solve for x, as we did in this example. Okay.